Okay, now we're good to go. Hello, everyone. Very nice to be here. We are just after lunch. We feel a bit heavy. I don't know about you, I do. So, we'll speak today about scaling Zabbix with InnoDB cluster. For the ones of you who came to the hands-on session this morning, you have already seen InnoDB cluster, and now we will answer to the question, what is InnoDB cluster and how it can serve to Zabbix for achieving scalability. By the way, before we start, this is by far the biggest, and from what I could see, also the warmest audience which I stand in front. So, time is flowing. So basically, 100% of organizations, they want their critical system to be highly available. And what's more critical than monitoring? Monitoring systems are our eyes into the infrastructure. They allow to see what's wrong, what could be better, so they potentially can save us a lot of money. So, does Zabbix needs to be highly available? Let's start with a question. Yes, indeed, it does, as you have already heard in the course of this conference. Because if your monitoring system goes down, you are basically blind and you don't know what's going on in your infrastructure. And there is no more scaring feeling than being like blind, totally in the dark. So, there are two ways to achieve high availability. One is at application server level, and one is at database level. Today, we will speak about high availability at the database level. Why? Well, because that's the topic I know the most. Then, so, MySQL is the #1 open source database, and Zabbix supports MySQL. Goes without saying. And it's used by also a bunch of other very successful companies around. But let's go into the core of the discussion. High availability with InnoDB cluster. So, how many of you know InnoDB cluster? Okay, better than I expected. So, yeah, at the beginning, there was the asynchronous replication. So we have one master server and multiple one or more slaves, which we're using to scale out reads, most probably. And there's a technology I will not speak much about, because we all know asynchronous replication. It has been around since MySQL 3, I think. And it's a very well-known configuration and very widespread. Although asynchronous replication had some minuses, had some limitations. So it did not perform failover automatically, and it did not resolve conflicts automatically. So replication has the nice habit to break quite often. So if the master goes down, unless somebody else takes a decision to reroute the connection somewhere else, the database system by itself does absolutely nothing. And in the case of a multi-master configuration, when there are conflicting writes on the database, also, unless somebody else, so the application, a human being, and so on, takes a decision, the database system does nothing apart from ending up in a split brain scenario. So this is exactly why in MySQL 5.7 has been introduced InnoDB cluster, which is a clusterization system which addresses the challenges which I have just discussed, and it's composed by three main parts. So the group replication, the MySQL shell, and the MySQL router. Let's see these components one by one. So the MySQL router is a tiny piece of middleware which is used indeed just to route the connections. So as we could see from the architecture, it stands between the application servers and the group replication setup with the scope of making the cluster transparent for the application, which will believe to talk to a single instance MySQL server. But indeed, under the hood, there will be a full-blown cluster. Goes without saying, the MySQL router is not a single point of failure because it can be deployed on parallel, since every router is a very much passive component that they will be not aware about each other, but it's ever not needed. They will just function independently. Then, in order to configure the whole thing, we use the MySQL Shell, which allows for it allows for several things. So it allows to have a modern MySQL command line interface, which supports JavaScript, Python, and SQL language, and related to clusterization, it allows to automatically deploy a cluster setup in 3 steps. I mean, the people which wake up early to come to the workshop have seen this. It's just 3-4 commands and the cluster is deployed. How many of you are using MySQL Shell? So for all the others, when you go home, you download MySQL Shell because it's free, it's available, and moreover, it's beautiful. And we come to the core component, the group replication. So what is group replication? Is a semi-synchronous replication topology with built-in distributed recovery, conflict handling, and distributed agreement, as you can see on the slide, which in the basics means automatic failover. So the group replication removes all the annoying work to decide how to fail over, so where either the application or either an administrator had to take the lead and decide where to route, to which slave to route the connections in case the master was failing. So more free time for developers not to have to code annoying failover logic, more free time for the administrators to focus on what's really important. So the architecture works as follows. There are the MySQL routers and there is the group, and the MySQL routers will route into the group of master servers, and those master servers can work in 2 modes. Single primary, where we write only on one server and we use the other servers for read-only. And this is a real read-only, not like the normal replication where you could anyway autonomously decide to write to the slave. This is an enforced read-only with the variable super read-only activated, so not even the root user can write into the servers. And multi-primary, where you read and write from pretty much every server. So a bit of theory, the group replication was implemented, it's an in-house implementation done from MySQL developers based on replicated database state machine and the Paxos algorithm, which has been, so I get often the question if there is which kind of implementation has been chosen. No one, it has been re-implemented in-house. So, in single primary mode, if something happens, failover happen. In the span of a few seconds, you will notice a small slowdown of the application, as we have seen this morning, and then another primary server will be chosen from the group. And when the original server comes in, you will receive the missing transactions in the form of binary log from the rest of the group before being accepted into the group back once again. Then, with what we get with multi-master functions of group replication, it's conflict detection. So basically, who first sends a comment, who first sends a query will get the query committed. And this is not based on time. Just for information, it's based on, the synchronized versions of write sets across the group. So this is really who first came in. Then, the building blocks of group replication. So there are two API components which are used to communicate on one side with the MySQL server runtime component in order for the MySQL server not to have to hook directly into the group replication and to keep the plugin independent and the code beautiful. And on the other side, to communicate with the other nodes via the so-called group communication engine, which is composed by all the communication APIs. And this is the place where the communication really happens. And the replication plugin, which is what handles the replication itself, so writes to the binary logs and reads from the relay logs. And this is what I've promised to the one of you who came to the workshop this morning, the life cycle of a transaction. So node 1 gets a transaction with all its statement, begin, commit, and whatever in the middle. The replication starts when another node, let's say node 2, certifies the transaction, which means writes the transaction to the binary logs. It sends a broadcast message to all the members of the group informing them about this event. And then node 1 finalizes the commit and sends back the response. This is done for ensuring data integrity. Then, performance. Discussing about performance, there has been this performance test done in-house by our product management and development. And this is the source. You can read the article. It explains very beautiful how it has been done, the test. And it has been done basically with durability settings every time on and off. And those are the results. So group replication had some, is just a bit slower than asynchronous replication for obvious reasons about how it works, but it has been showed way slower than competing products. Then, Zabbix, let's see, Zabbix HA deployment with MySQL InnoDB cluster. So there are some requirements for the InnoDB cluster, which are the InnoDB storage engine, obviously, it's called the InnoDB cluster, then a primary key or a primary key equivalent, so non-null unique index on every table. It requires the GTID turned on. It does not support concurrent DDL statements. It does not support transaction isolation mode serializable. And it does not support cascaded foreign keys, but I have checked with the Zabbix team. Those are things which the Zabbix database does not use, so we're safe. Some notes on the hardware. It needs 3, 5, 7, or 9 machines per group, maximum 9, an odd number of machines. And of course, the usual for a high availability setup for performance limit, virtualization layer, high-speed network, high-speed SSD disks, this kind of things. So nothing extraordinary, runs on commodity hardware, and every server keeps an identical copy of the data. Then, InnoDB cluster with 3 nodes. This is a Zabbix deployment with InnoDB cluster. MySQL router on each app server installed in Zabbix. Set up or clone the database, then create the InnoDB cluster, point the router, and point the application to the router. Well, what more? Monitoring, administration, how to do it. Well, if you came this morning to the workshop, you have seen what more. If not, well, there is a full-blown documentation which explains it. So, in conclusion, Zabbix takes care of your infrastructure. So, why don't we take care of Zabbix, making sure it's highly available with InnoDB cluster? And before I finish, since I cannot reclamize my workshop anymore, at 4 and 10 minutes there is a lottery where I will be giving out a MySQL book. If you want to register, come to the booth. And having said this, thank you for your attention. It was a joy to be here. Hopefully see you next year.